Good morning, Meredith. We are starting cell transport in class, so I wanted to just give you this quick little rundown. Cell transport is just how do molecules move in cells, into and out of cells. And the cell membrane, remember, is selectively permeable, and so it regulates what enters and exits. Now, there's two types of cell transport. There can be passive transport or active transport. And in passive transport, you're not going to have any energy, so molecules are going to move from high to low concentration. And in active transport, it requires energy because you are moving molecules from low to high concentration against the concentration gradient, so it requires energy. And passive transport, there's basically three types. You have diffusion, which is just the movement of molecules from high to low concentration. You have osmosis, which is the diffusion of water from high to low concentration across a membrane, and facilitated diffusion, which is the movement of molecules from high to low concentration across the membrane with the help of proteins that are embedded in the membrane. So the proteins are helping or facilitating that diffusion. In active transport, you have endocytosis, which is the movement of large molecules into the cell, and that there can be two types. You have pinocytosis, which is liquid particles, and phagocytosis, which is solid particles. And then when the cell expels large contents out of the cell, it's a process called exocytosis. But this activity is going to focus specifically on osmosis. So what we did was I took some eggs and I soaked them in vinegar overnight, and that removes the shell. So it ends up looking something like this. And then we put them on a balance and we weighed them, and we took an initial weight or mass. And then what we did is let them sit overnight. And we were trying to determine, is water going to move into the cell, which is represented by the egg, or is water going to move out? And that would have to do with where water was more highly concentrated. So in this situation, we put the egg in corn syrup. And the next day, you can see, obviously, that the water moved out of the egg, which indicates that there was a higher concentration of water in the egg than what was in the corn syrup. In the other cup, we took the egg and we put it in pure water, 100% distilled water. So obviously there's more water in the cup than in the egg, so the water moved into the egg. And then what we did was we put them on the balance, turn it on. You want to make sure that it's in grams, and you always want to put a paper towel on your balance. And then you want to tear it back to zero so you don't have the weight of the paper towel. And then basically just weigh the eggs. And so that went down to 35. So the initial was 78 and 35 was the final. So you can see it lost, what, 43 grams of water. Now, on the other one, it started off at 74, and the final mass, this one, is 83. And so you can see that it gained some water, where the water moved from outside, you know, what's in the cup into the egg, but it didn't increase nearly as much as the decrease. And that's because of the pressure of the cell membrane limiting the amount of water that can get into the egg. But in the cup, there's still space for the water that's leaving the egg to move around, so there's not a pressure preventing it from moving out, so more could move out. So that's our process for this week, and I hope this is helpful for you. And I'm going to send you a little worksheet to review, and it'll look something like this. If you come up here, in this beaker, you can see that it's isotonic because there's an equal concentration of solutes outside and inside, and there's an equal amount of water outside and inside the cell in that beaker. And if you have an equal concentration of solutes and water, molecules are going to move in and out at an equal rate. So that's isotonic. Iso means the same. In a hypotonic environment, hypertonic, there's going to be a higher solute concentration. So hyper means higher. So to name the solution, you look at the solute. So that's a hypertonic environment. And so in order for that environment to be hypertonic, if it's 20% solute outside, then inside would have to be anything less than 20. So I could say 15% and 85%. And that would make this solution hypertonic because it's higher solute here. But then to tell me what happens, you look at the water, and based on osmosis, water moves from high concentration to low concentration. So water is going to move out of the cell, and the cell is going to shrink. Okay? And that's what happened to the egg in the corn syrup. It was in a hypertonic solution. In the last situation, we're going to look at hypotonic environment. So again, if we start with that 20% solutes and 80% water, and I want there to be less solutes outside than inside because this is a hypotonic environment, hypo is less than, then it can be anything above 20. So we could say 25% solutes, 75% water. Okay, so to name the solution, you look at the solutes. 20 is less than 25, that's why it's a hypotonic environment. And then to tell me what happens, you look at the water, and so you're going to go from 80 to 75%. Water is going to move in. This cell is going to swell. Okay? And I hope this helps, and I hope you have a great weekend, and good luck on the test that I posted. I'll see you later.